4.6 billion years ago, a giant molecular cloud collapsed, forming our solar system. As gravity drew matter inward, the center of the swirling cloud ignited, giving birth to our sun. Let's rewind the cosmic clock 4.6 billion years. Picture a vast dark cloud of gas and dust, a nebula adrift in the cosmos. This nebula, seemingly tranquil, was a cradle of potential, waiting for the right conditions to ignite a cosmic transformation. Gravity, the architect of the cosmos, took hold. This invisible force began to weave its magic, pulling particles together, setting the stage for a grand celestial event. The cloud began to collapse inward, drawn to its own center. This collapse was not a simple event, but a complex dance of particles, each one playing its part in the grand scheme. As it contracted, it spun faster and faster, transforming from a formless cloud into a swirling disk. This spinning disk was a hotbed of activity, with particles colliding and merging, creating the building blocks of our solar system. At the heart of this maelstrom, temperature and pressure soared. The intense heat and crushing pressure were the perfect conditions for nuclear fusion to begin. From this cosmic ballet emerged a star, our very own sun. This new star was the anchor of our solar system, providing the energy needed for the next stages of planetary formation. Initially, it was a dim and temperamental infant, prone to outbursts of intense radiation. These early solar flares were both destructive and creative, shaping the environment around the young sun. But over time, the sun matured, its fusion furnace stabilizing, bathing the surrounding disk in its warm glow. This steady energy allowed the particles in the disk to cool and coalesce. Close to the sun, where temperatures were blistering, only heavier elements like iron and rock could withstand the heat. These elements began to stick together, forming larger and larger bodies. These elements coalesced to form the inner rocky planets, Mercury, Venus, Earth, and Mars. Each of these planets has its own unique story, shaped by the conditions in this early solar system. Our first stop on this cosmic journey takes us to Mercury, the smallest planet in our solar system and the closest to the sun. Imagine a world of extremes, where the sun blazes in the sky, nearly 3 times larger and over 7 times brighter than it appears from Earth. A single day on Mercury, from sunrise to sunrise, lasts a grueling 59 Earth days. In contrast, a year on Mercury, the time it takes to complete one orbit around the sun, is a mere 88 Earth days. Despite being just a fraction of Earth's size, Mercury is incredibly dense, the second densest planet in our solar system after Earth. Our next destination brings us to Venus, a planet often referred to as Earth's twin, and for good reason. Venus is remarkably similar to Earth in size, mass, and composition. But don't let these similarities fool you. Venus harbors a dark secret. Beneath its deceptively serene swirling clouds lies a hellish landscape, a testament to the power of a runaway greenhouse effect. Venus's atmosphere, composed primarily of carbon dioxide, traps heat from the sun, creating a scorching surface temperature of over 900 degrees Fahrenheit. The pressure at the surface of Venus is equally extreme, over 90 times greater than Earth's atmospheric pressure at sea level. Venus's clouds, while beautiful from afar, are composed of sulfuric acid, a highly corrosive substance. Chapter 4. Our cosmic journey now takes us to Mars, a planet that has captivated humanity's imagination for centuries. Mars, named after the Roman god of war, has long been associated with the possibility of extraterrestrial life. While those canals turned out to be an optical illusion, Mars continues to beckon us with the tantalizing possibility that life may have once existed there. Mars is a cold, dry desert world today, but evidence suggests that it was once a much warmer and wetter place. This ancient history, combined with the presence of organic molecules, makes Mars a prime target in the search for extraterrestrial life. Chapter 5. Our cosmic voyage now takes us to the outer solar system, to the realm of gas giants, where Jupiter, the largest planet in our solar system, reigns supreme. This colossal giant is not just a planet, it's a world of wonders and mysteries that continue to captivate scientists and astronomers alike. Jupiter is a colossal world, so large that over 1,300 Earths could fit inside it. Its sheer size is mind-boggling, dwarfing all other planets in our solar system. If Earth were the size of a grape, Jupiter would be the size of a basketball. Imagine a planet with no solid surface, just a swirling atmosphere of hydrogen and helium. This immense gaseous envelope is constantly in motion, creating mesmerizing patterns and bands that are visible even from Earth. Jupiter's atmosphere is a tapestry of vibrant colors, a result of complex chemical reactions and powerful storms that rage for centuries. These colors range from deep reds and browns to bright whites and yellows, painting a dynamic and ever-changing picture. One such storm, the Great Red Spot, is a swirling vortex larger than Earth. This gigantic storm has been raging for at least 400 years, and possibly much longer, showcasing the raw and relentless power of Jupiter's atmosphere. Jupiter's immense gravity doesn't just affect its atmosphere, it also plays a crucial role in shaping the entire solar system. Its gravitational pull is so strong that it influences the orbits of other planets and even helps to keep the asteroid belt in check. Jupiter acts as a cosmic vacuum cleaner, its gravity deflecting comets and asteroids, protecting the inner solar system from potentially catastrophic impacts. Without Jupiter, Earth and its neighboring planets would be far more vulnerable to these space hazards, making Jupiter a true guardian of our solar system. Chapter 6. Our next destination takes us to Saturn, a planet that has captivated stargazers for centuries with its stunning ring system. Imagine a planet adorned with thousands of shimmering rings, each one composed of countless icy particles. These particles, remnants from comets, asteroids or shattered moons, orbit Saturn in a delicate gravitational dance. Saturn's rings are not solid structures, but rather a vast collection of individual particles, each one orbiting the planet independently. The origin of Saturn's rings remains a mystery, but scientists believe they formed relatively recently, perhaps within the last few 100 million years. Chapter 7. Our journey through the solar system now takes us to Uranus, a planet that stands out from the crowd with its extreme tilt. Imagine a world tipped on its side, its axis of rotation almost parallel to its orbital plane. This unusual orientation means that Uranus essentially spins on its side. Scientists believe that this extreme tilt was caused by a cataclysmic collision early in Uranus's history. Uranus is often referred to as an ice giant, a term that reflects its composition. Unlike the gas giants Jupiter and Saturn, Uranus and Neptune have a higher proportion of heavier elements, including water, methane and ammonia. These compounds give Uranus its distinctive blue-green hue. Chapter 8. Our final destination on this cosmic journey takes us to Neptune, the eighth and farthest planet from our Sun. This distant world, shrouded in mystery and wonder, beckons us to explore its secrets. Neptune, named after the Roman god of the sea, is a world of deep blue hues, a color that reflects the presence of methane in its atmosphere. This methane absorbs red light and reflects blue, giving Neptune its striking azure appearance. Neptune is a giant planet, slightly smaller than Uranus, but more massive. Its immense size and mass make it a fascinating subject of study for astronomers and scientists alike. It is a world of extremes, home to the fastest winds in our solar system with speeds exceeding 1,200 miles per hour. These winds are so powerful that they can whip up massive storms and create dynamic weather patterns. These powerful winds, combined with Neptune's internal heat source, drive a dynamic and ever-changing atmosphere. The planet's internal heat, which is still not fully understood, contributes to the violent weather and turbulent conditions observed on Neptune. Neptune's atmosphere is adorned with dark spots, swirling storms that come and go. These storms, similar to Jupiter's Great Red Spot, are massive and can last for years, providing a glimpse into the planet's complex meteorological processes. Neptune has 14 known moons, the largest of which, Triton, is a fascinating world in its own right. Triton is unique because it orbits Neptune in a direction opposite to the planet's rotation, a phenomenon known as a retrograde orbit. This suggests that Triton may have been captured by Neptune's gravity long ago, adding another layer of intrigue to this distant moon. Outro. From chaotic beginnings to the orderly system we see today, our solar system's formation is a tale of cosmic wonder. Each planet, a world unto itself, holds clues to the universe's grand design. As we continue to explore our cosmic neighborhood, we deepen our understanding of our own planet's place in the grand tapestry of the cosmos.